Pathogenesis and immunology of leprosy. Though Mycobacterium leprae was the first bacterial pathogen in humans to be described, it remains one of the least understood because it has not been possible to grow this bacterium in culture media. Leprosy is a slow communicable disease, and the incubation period ranges from few months to as long as 30 years. It is not known exactly how this disease spreads from person to person. Transmission most likely happens when a person with this disease coughs or sneezes, and a healthy person breathes in the droplets containing the bacteria through nostrils. And since the bacilli has affinity for cooler parts of the body like nasal mucosa, skin, peripheral nerves, and Schwann cells, they migrate towards these structures in various possible ways. In the nasal cavity, mycobacteria are capable of infecting nasal epithelial cells with the help of adhesins located on their surface, such as histone-like proteins and heparin-binding hemagglutinin proteins. Then they directly invade the epineural sheath of nasal sensitive fibers without traversing vascular route. They reach the endoneurium, the innermost layer of the nerve fiber which surrounds the axons. Mycobacteria eventually invade the Schwann cells and start multiplying very slowly. When the multiplication progresses unchecked, it results in the destruction of the Schwann cell, after which the bacteria are liberated from the destroyed cells and enter other unaffected cells. Mycobacteria can infect any part of the respiratory epithelium. And most efficaciously, alveolar epithelial cells. Once the invasion of the respiratory epithelium occurs, they cross the basement membrane and the underlying connective tissue in order to reach the blood vessels. Once the bacterial load increases in the blood and infection is recognized by the immunological system, inflammatory cells such as macrophages reach the site and engulf the culprit bacteria. From there, bacteria can spread hematogenously and reach skin or peripheral nerve trunks in an asymmetric fashion. Normally, macrophages from blood can patrol nerves to carry out homeostatic repair functions. Macrophages infected with Mycobacterium leprae also reach the peripheral nerves through the bloodstream and aggregate with other macrophages, forming granulomas. Mycobacterium leprae has a specialized surface, phenolic glycolipid 1, PGL1, that causes infected macrophage to produce an excess of nitric oxide, which has a damaging effect on the mitochondria present inside the axon of nerve fiber. If the nerve fiber is myelinated, the myelin sheath gets destroyed. Which is manifested as localized protrusions on the peripheral nerve. This results in impairment of sensation and widespread peripheral neuropathy, which can externally manifest as various skin lesions such as hypopigmented patches or nodules. It is very obvious that nerve damage is not initiated directly by mycobacteria, but by an over-exuberant response of macrophages to bacteria, which is a delayed or type 4 hypersensitivity reaction. Basically, after entering the Schwann cells or macrophages, the fate of the bacteria depends on the resistance offered by the infected individual towards the organism. Normally, specific cell-mediated immunity provides protection to a person against leprosy. Good specific cell-mediated immunity successfully limits the disease to the nerve Schwann cell, resulting in occurrence of pure neural leprosy, leading to paucibacillary type of leprosy. If cell-mediated immunity is deficient, the disease spreads uncontrollably and produces multibacillary leprosy with multiple system involvement. However, this disease has low pathogenicity. Only a small portion of infected people develop the signs of disease.